Hi everyone, this is Peter Ma. I'm a part of the Intel Innovator software innovator, and this is for what the IoT development from prototype to production. So in this session, we're going to talk about anti-snoozer and the vehicle rear vision as our example of using how we can use DIY type of IoT devices to improve your car experience. Yeah, you can kind of see my slides on the Google Docs as a post-it. So here it is. Um, so we're talking about smarter cars, how IoT can improve your current driving experience. Again, I'm part of the Intel software innovator, Samsung champion. I've been through 5 different startups, and I've attended over 100 hackathons, and I won kind of most of them. I've, outside of hacking and doing startups, I've traveled more than 33 countries in past 3 years. So I do a lot of traveling to kind of get experience of what's outside of the States. There's a lot of ways of how to make your car smarter with the current stuff you have, mainly with a couple of Intel, the Arduino 101 or Intel Edison, along with a couple of sensors. Specifically, we're going to talk about anti-snoozer, vehicle rear vision, car sense, and we discuss about what are other possible ideas. Anti-snoozer, we're going to do mainly 2 things. First is like the anti-snoozer, we're going to talk about how it's built and what is required and what I have gone through. And then the second portion is how to build the vehicle rear vision. So anti-snoozer is a facial detection system when people are falling asleep at the wheel. So 60% of adult drivers, that's about 160 million people in America, says that they have driven in a vehicle feeling drowsy in the past year. This was taken by the National Sleep Foundation's 2005 poll. And what anti-snoozer is using facial detection for user falling asleep behind the wheel, specifically detecting yawning, blinking, eye closing, and looking around. And also the special part about this was built 2 years ago in combination with using RealSense SDK, which is the PC, and Intel Edison. It's open source with a guide on how to build it. So let's go through a little history about this. So this was when we first building this at the AT&T Developer Summit with Intel's help. And that was one of the first time where you can connect the RealSense camera with your Intel Edison as part of the IoT. This is when my sister was pitching after we building it, and we were able to win the grand prize for the AT&T's Developer Summit. That was we got over around $50,000, including the grand prize of $25,000. And the Intel along with other awards. So after winning the hackathon, I did a lot of upgrades, and this was able to win the RealSense App Challenge. We built the demo in a way where it can be actually demoed inside the AT&T Drive Studio in Atlanta. And later that year, this was selected as part of the semifinalists for China US Young Maker, as well as being part of the demo as well as a keynote in IDF 2015 in San Francisco. In 2016, this was selected as part of the demo for China-US people-to-people exchange. And this is an AT&T Drive Studio. This was part of the, being semifinal China-US Young Maker. My sister was able to make it there. And during the IDF, Intel IDF developer forum, this was actually part of the opening keynote as what you can do with the Intel technology. And later, that you obviously can see, we give a pretty good demo during that session. And last year, this was selected as part of the China's China-US people-to-people exchange. Secretary of State John Kerry, along with the U.S. ambassador to China, as well as the vice premier of China, was able to test this in the first hand. So from a hackathon project, it's also received a lot of press coverage, including Vice Motherboard, Fast Company, Forbes, Intel IQ, and being featured on both the Intel and AT&T dev stories. Now let's go through a little bit of what hardware is required. It's pretty simple. It's just the Intel Edison board with the Arduino breakout board, using the Seed Grove, which is, Grace has talked a lot about the actual IoT kit, and the Grove kit is part of it. We need a fourth generation, which is Haswell or later Intel Core. This is to run the actual RealSense demo, and F200 camera, and that's all you really need to get this running. The software required is you need the Windows 8.1 or 10 or above at this point, Visual Studio 2013 or more, RealSense SDK, and Arduino IDE. And this is where I wrote a guide 2 years ago on how to connect Intel RealSense technology with Intel Edison. There's two ways of doing this. First is that you can do this directly through USB hub, or you can use COM ports, like the one I showed above. Or the second way is you can actually run everything through Wi-Fi. So you can communicate your computer with your Intel Edison or other IoT platform through the Wi-Fi port. And this is what a final product would look like with the laptop. I have pretty much open sourced the entire guide on Hackster.io. If you're interested in downloading, feel free to go there and download the entire guide. It can be complicated. It can be simple. Simple part is the Arduino code is simply running through the IoT kit. What you're using is a vibration sensor, the buzzer, as well as the crystal LED display. Those are only three things that's being used, and then running through I2C port as well as the analog port. The RealSense sample guide will pretty much run through 90% of your code. All you really need to do is figure out how to communicate that through the USB port. The next step for the project is that, so currently the last generation RealSense SDK is obsolete by now. So the next generation SDK is basically using the LibRealSense that is running on Linux. So what we're going to do next is basically going to use Intel Joule, Ubuntu, and the R2 camera, and that is coming up very soon this year. The reason why, the reason why first is that I've been trying to shrink the size of the anti-snoozer demo into a complete independent IoT chip rather than using a computer. The reason why for that is first of all, it has price point. An IoT device is much more cheaper than buying an actual fourth generation Intel computer. And second is it's a size point. Using one single chip, it is much more smaller than having multiple devices communicating with each other. And Intel Joule kind of is best for in both cases. Of course, the RealSense does not detect facial tracking, so additional software from OpenCV have to be used. So what I will be using is Iris, and this again will be open source by later this year because I just finished the other project. Any questions about anti-snoozer? So you ask, do you have instructions on the build? You can't use Linux or Mac. The current version of anti-snoozer cannot use Linux or Mac. This you have to do on the next generation because the original Intel SDK, the RealSense SDK, was only built for Windows. So another sourcing part is that the Intel have shifted the entire focus from having a RealSense with a PC into independent IoT devices. I built this before it was basically supported in Linux. This was 2 years ago. So wait for the next version of this, and I'll keep the people updated. As you can see, the next demo is basically complete using Linux. So let's talk about vehicle rear vision. So the first example, we basically talk about how I built this and then where it went through. In the second example, I am going to focus more on how exactly this was built, step-by-step process. So why these cameras run only on USB 3.0? So RealSense camera only run on USB 3.0 because it contains multiple cameras in there. There's a 2 visual camera and a 1 infrared, and along with all the logic in it, the data transfer is more than what USB 2.0 can handle. So that's a reason why. It's based on general spec. Let me disable screen sharing for a second. This is a general, RealSense developer kit. This is on the F200, and these are R200. So that's the basic Intel spec. It's not something that I can control. On Intel Jewel kit, specifically on the Intel Jewel kit, the port is using USB 3.0. So some people have been able to run this with the Windows 10 IoT Core, but I was not able to because I'm upgrading this entire thing to Linux. So I didn't really want to bother with using the Windows 10 IoT Core. So Sunny, the Intel Jewel is expensive right now. Currently, the problem with Edison is that it does not support. It's not powerful enough to run a RealSense camera. The future version of it, you can. I'm going to try to see. And the second problem with the Edison is that it doesn't really have a display port, so we can't really run the displaying. We can't really. How would I explain this? We can't really hook it up to a monitor and see what's going on. The future version of it, it still requires Ubuntu to actually be as a basic operating system. So that's Edison is simply not powerful enough to handle all this. And on top of it, Intel Edison only have a USB 2.0. It doesn't really connect with the 3.0. The Jewel, the price will drop on these things. It's just when it first come out, like any products, when it first comes out, they always have expensive price point, and eventually the price will drop to the people can massively adopt it. That's kind of true with any technology. Any other questions on this? Yeah, you're welcome. Let's move on to vehicle rear vision. So with vehicle rear vision, what it is a backup camera for the cars that is not equipped with it. So around 7,475 children under age of 15 were treated as automobile backup incidents. About 300 fatality per year result from backup collision. And this is from U.S. Center of Disease Control reporting from 2001. The range of R200 can go up to 4 meters in the daylight, around 1.5 meters in using its own infrared camera. For the F200, which is front facing, have a lot more shorter range. So that's why the F200 is good for using cases like anti-snoozer, where it can basically detect a person's face while driving, but it's not good at detecting the the backup car situation. And I'm gonna explain that very soon. That's just in 2018, all the cars sold in the United States have to be equipped with the backup safety camera. What is the vehicle rear vision? As you guys probably know, majority of the cars out there does not have any camera system or even display system in the car. So we're basically building a vehicle backup camera system for them. It'll be using computer vision for detection, and you can kind of build this yourself at home. This was selected as part of the Intel Early Innovation Project, and they were able to fund me with a lot of tools as well as hardware to build this, including the Intel Joule. So let me see if you guys can see this video. Over 2,500 children in the United States gets treated for vehicle backover incidents every year. And only luxury cars usually have backup cameras. We decided to build backup camera for the cars that does not have it. Okay, everything should start automatically as real IoT devices do, according to the guide. Let's take a look at the Android app, whether it actually ran. Nope, not yet. Takes a little time. Okay. Whoa! This actually works. You can see the camera's right here. The distance of the Wallaby should be right here. All right, and then the casing is still being printed. Once that's done, we're gonna install this on our car. Okay, let's now test this for real. As you can see, there's a Tesla right there. That's my Tesla. If we screw up, we're gonna crash into Tesla. Let's see how vehicle rear vision would work. Okay, getting close. Oh, now I can see this 95, 70. Ooh, 47. Okay, I think that's a little too close for me. Let's go outside and take a look. As you can see, there's still a little more. This is Wallaby, the reconnaissance camera, using Intel Joule that's connected. In the front, we have our Android app that's really just attached to a duct tape right here. Using the camera, we can also see the pedestrians around. Something that the mirror doesn't really tell us much about, especially when there's a child or a pet. We can also try some parallel parking. All right, so that was an embarrassing video that I've made. As you can see, the hardware requirement is pretty simple. It's basically using a radar, Intel Joule, and the R200 camera, along with any Android tablet or phone, doesn't really matter, with a car adapter. In this case, like earlier when you asked when Intel Joule is too expensive, you can actually use a much cheaper chip that's as long as it can run Ubuntu. With the USB 3.0, we're pretty much fine with it. And I'll explain later why if you would decide to use Intel R200 camera as part of the distance sensing, then the R200 camera is required. But if not, you can use any other webcam or wide angle camera. That would actually work as well, because the radar is used for detecting the distance, and this is what it looked like. Literally just a duct tape with a bunch of stuff on it, as you can see. So that was first step, get the requirement info for all the items. Step number 2 is basically install Ubuntu on the Joule. Once you can, there's an entire guide on the Ubuntu's website on how to install Ubuntu on Joule. If you were to use any other chips, again, just all it requires is get the Ubuntu installed on there. And third is streaming through RealSense camera. In this case, we use the motion library, and what you have to do is just change the config in there for a specific port, a webcam, and then you put that in put that as a startup. So once the Ubuntu is loaded, the entire motion gets loaded. It's very the process is very, very similar to, let's say, like your security cam. It's actually, I took the open source code from the security cam and rerouted this way. This is what it looked like when it you actually run the entire camera on there. This is all it contains. The tiny little spot there, that's for keyboards and mouse, which is not really required once everything's installed. Step number 4, set up the radar. Using a radar, you will have a lot more accuracy out of the devices than the camera. Like earlier from the demo, you can see I can get that up to around 20 to 30 centimeters accuracy. How we're going to communicate is through a UDP port. Instead of we're going to transfer it through sockets directly into the Android or any other device. It's actually using Mac to test that out. And number 5 is setting hotspot from Joule. Again, this is just one line of code above. This will allow you to do both data transferring as well as streaming videos. As long as you put that line of code in right up front, you'll be totally able to run this. And step number 6 is that you basically building an Android app. As Android app starts, the app should automatically connect to the hotspot, which the Ubuntu have created. And once it's connected, we're basically streaming motion. We can stream the entire motion from RealSense, like earlier, as part of the test. It's just part of the webcam system. And the third is that we have to read the radar data from the socket via UDP. And when everything's created, just test out everything. This entire process probably takes it took me around 24 hours on the first try. So I think, with a guide, you guys can probably do this within 5-6 hours. And that's what it looked like when everything started running. When everything's finished, I actually printed a case, just fit in the entire R200 camera. But if you're not using this camera, you can actually do something else. So the installation process is rather simple. Let me run this. So in the installation process, you simply take out, the license plate, and you drill the regular license plate on there. There is a converter there's an AC to DC converter out of the cigarette how do you call those? The electricity socket from your car. Transfer that into the DC socket, and I basically use that to, as you can see on the right side. That's the only thing I'm using to power up this entire thing. And the Android tablet was literally attached with a duct tape. In this case, you can see literally everyone can build this. The software actually works on both phones as well as tablets. For all of these tablets people have sitting in their garage, now they can put these to some use. That's installed, and this is what it looked like afterwards. And when you're testing, you can actually see the little dogs as well as pedestrian behind you. So the next step is like currently, as I explained, the current project does not really require Joule. As long as you can run Ubuntu with a radar, you pretty much can detect the entire build out the entire thing. The next version is basically to make it more accurate. I'm going to use a lot more computer vision on the R200's capability of sensing what's going on. Adding that on top of radar to have a better rating of the surrounding. And also, we're going to build a next generation enclosure, so I don't have to duct tape everything onto like the side of the car. As you can see, they just really need a hub, as well as just need a hub to contain the entire Intel Joule chip. And also, entire project is open sourced. Feel free to go to hackster.io. So this is a step-by-step guide. Of all the details of what to actually change. Again, first run motion, second run the Wallabout radar as part of the startup. So this way you know how much centimeters coming in. The third is creating the hotspot. And once Android is starting, you can basically test all of that out. Yeah, since the Intel Joule was sponsored by Intel as part of the early innovation project, you can try to build this using other devices. Any other questions before we move on to the next section? And previous one, let me show you the previous one as well. I haven't been working on anti-snoozer for a while, so that's why I'm going to move that into Joule as well. Okay, so next we're going to talk about CarSense. It's an alert system for hypothermia for kids in cars that's left in the car. So child heat stroke death is around between 1990 to 2016. There's 793 cases, and these can be easily prevented. What I built was, people the problem was people leaving their pets in the car all the time. So what I built is just combining infrared sensor as well as temperature sensor. That with the Edison was able to connect. So when how do I explain this? I haven't pitched this for a long time. Whenever the car is increasing heating, and then the infrared sensor detects there's a live beam in the car, you will automatically get a text message. And this was part of the winner for Intel's IoT Roadshow back in 2014. In Mobile World Congress, I give a demo in Barcelona. But later that year, Intel found a better solution, which is just making sure that your kid you never leave your kid in the car. And because of that solution is much better than what I came up with, I decided to just open source a project and leave it alone. Sometimes you have to figure out what are the better solutions than your own. Well, some of the future projects I like other projects and the future projects I've been working on is first of all, the Drive VR. We created a VR experience for driving school. This way the users can actually test out the entire driving experience before they get in the car. And then we look at all the other features a luxury car have, and then see how we can use IoT device to create a guide for people who want the exact same feature, just like the vehicle rear vision, especially when it has something to do with safety. I played it with putting the emotions while person's driving. And then the data is actually seeing how traffic have caused stress in people's life. Collision detection, as well as some of the new type of UI that car can come up with. And the most interesting one is creating a heads-up display for cars. So, because that's, I think, is going to be very popular in the near future, because if it's cheap enough for everyone to create it, it's going to be a great tool. Or you can just buy, a Tesla, and then will have all those features. And to see how you can improve the newest cars, and at the same time be backward compatible for all the old cars. And again, my name is Peter. HUD is heads-up display. So a heads-up display is basically using projection on the front on the windshield. This way you can display more information for things like GPS, navigation, and as well as other essential informations like your gas is running out. And those are something that literally with less than $200 worth of material, we can actually build it out. If you find it on market, we can actually go for a Kickstarter campaign. We can discuss about DevMesh. So majority of the stuff that I've done is posted on DevMesh. I will give you guys a link. Currently, the vehicle rear vision is being featured on there. Feel free to check out all the other projects that's on there with the specific guides. If you guys have any questions, feel free to email me and let me know if you have good ideas of improving the current car. In my own opinion, the best way of improving driving experience in the very near future is creating a better battery. But how to do that is much more difficult than a single discussion. These are general tools that I have for building different things. Have a great weekend and enjoy all the other sessions.